Problem number 24 deals with something called a chain letter. Now, a chain letter is something that used to happen quite some time ago, so I don't think any of you guys are ever really familiar with this nowadays. But it works, as it says in the text, as follows. One person sends a copy of the letter to 5 friends, each of whom sends a copy to 5 friends, each of whom sends a copy to 5 friends, and so forth. And the question in your text says, how many people will have received copies of the letter after the 20th repetition of this process, assuming no person receives more than 1 copy? Chain letters were a popular scheme, a century ago, because what you would do is you wouldn't just send out the letter. In the body of the letter, you'd be asking to send someone $1. So what you might do is you would put the name of 4 of your friends on a list, and put your name at the bottom of the list. So it's a list of 5 people. All of them are friends of yours, and you're at the bottom. You send this letter to 5 other friends, and you ask them to send $1 to the first name on the list, and then take that name off and put their name at the bottom, and to keep this going. Now, why would you do this? Well, if you do this, you see that when you start out and there's just one person distributing this, what will happen is for the second chain, what happens is you're going to end up sending out 5 letters, and then we're going to do 5 times the 5, or that's going to be 25 letters, and then it's going to be 5 times the 25 for 125 letters, and then 5 times, let's do this, the 125 for 625 letters, and then 5 times the 625 for 3,125 letters. So you see, after 5 iterations, this thing's gone 5, 25, 125, 625, 3,125. In other words, if we do this the way we would write it, we start at 0 with 1, and C sub 1 is 5 to the first times 1. C sub 2 is 5 squared times 1. C sub 3 is 5 to the third times 1. C sub 4 is 5 to the fourth times 1. C sub 5 is 5 to the fifth times 1, right? You see, if you put your name at the bottom of the list, and it actually goes through and gets out to 3,125 people, well, after a little while, you're going to get 3,125 envelopes with dollar bills in them. Not a bad thing if it was done in the era when $1 was a lot of money and the postage was only 2 or 3 cents. A little bit tougher now. But do notice how this thing works as you go along. If you were to go out to the 20th time using this pattern, that's going to be 5 to the 20th times 1, because our geometric sequence, and we should have identified this as a geometric sequence, is that C sub n is equal to 5 to the n. But the question's really asking us here is how many total people are doing this, not just how many people get it on the 20th iteration. So what it's asking us for is when you start at 0 and you go up to 20, what is 5 to the k? Well, we've done that problem before, and we know that it's going to be 5 to the 21st. I didn't write that very well. Let me write it over again. It's going to be 5 to the 21st minus 1 over 5 minus 4. Sorry, 5 minus 1. So this is 5 to the 21st minus 1 over 4, which is approximately 1.192 times 10 to the 14th. That would be like 119 trillion people, which is more people that are on the planet by a factor of about 10,000. So you see, this cannot work. This is what we would call a pyramid scheme, and this is what this is the reason why the post office has made chain letters illegal. Now, the same thing can happen nowadays by making up, if you want to do something illegally, any kind of a Ponzi scheme, or you might see this happening in social media. Certainly you've never gotten something that says, please copy this item here in Facebook or whatever, whatever your favorite social media is, and send it to 5 of your friends or 7 of your friends or whatever. Well, they're all going to go up geometrically, and they all have to break down fairly quickly because there just aren't enough people on that social media to keep it going.